Let's start your snap interview for RCC as you have interview for HPCL. So first of all, introduce yourself.
So good morning, sir. Thank you for giving me this opportunity. As you mentioned, my name is Kumar Divyansh and I belong from the land of Buddha, that is Bihar, from city Patna. I did my initial schooling from Kolkata and then I moved to Bihar. And did my schooling till 12th from Patna. I did my graduation in civil engineering in 2023 from NITIE Rourkela in Odisha. Currently, I am pursuing my MTech in Geotech Engineering from IIT BHU. I've been involved in quite many activities since my college days. And apart from that, my hobbies are playing cricket and reading books. Thank you.
Okay. So tell me what is the difference between the pre-stressed concrete and the normal concrete section?
तो सर इन प्री स्ट्रेस कंक्रीट व्हाट वी डू हम लोग उसमें कंक्रीट को एक प्री कंप्रेस कर देते हैं ताकि कंक्रीट कैन टेक ऑन टेंशन whereas in normal concrete we do not do that.
अगर आप पहले ही कंक्रीट को स्ट्रेस कर दे रहे हो तो लोडिंग के कारण तो स्ट्रेस ज्यादा आएंगे फिर. व्हाट डू यू थिंक?
एक्चुअली सर उस हम लोग क्या करते हैं वी पुट अ reinforcement steel जिसको हम लोग टेंसाइल स्ट्रेस देते हैं एंड दैट रिएक्शन ऑन द कंक्रीट इज ऑफ कंप्रेसिव फोर्स. तो कंक्रीट फाइबर्स ऑलरेडी कंप्रेसिव स्टेज में चले जाते हैं. इस वजह से सिंस वो कंप्रेस्ड रहते हैं तो वो टेंशन भी थोड़ा बहुत ले पाते हैं. थोड़ा बहुत नहीं, अच्छा इन अ सिग्निफिकेंट मैनर, क्योंकि कंक्रीट इज वीक इन टेंशन.
सो कंक्रीट यहाँ पे टेंशन भी ले रहा है.
यस सर.
सो टेल मी द assumptions in the LSM for the
So
beam
as
design.
okay, sir. So in LSM, the first assumption is that the stress strain curve of uh, the steel reinforcement is initially parabolic, and then after a certain stage, it is rectangular.
This is
दूसरा
for the steel.
assumption, yes, sir, that is for the steel.
That is not
Uh,
for the steel, but as per in code, if you see the IS
Sorry, sir,
456,
that is for concrete. I beg your pardon, sir. That is for concrete. And then
is it always true we have this combination of parabola and rectangle?
yes, sir, in LSM, it is always true.
Suppose if we are getting the any other shape, like trapezoidal or any other shape, then what do you think?
So then modifications can be made, but in limit state method, that is the shape of stress strain curve. And the other assumption are that we overestimate the applied load and underestimate the stress bearing capacity of the structure. So for that we use partial safety factors.
So
The
what is the meaning of this overestimating the load?
overestimating the load means the, whatever the applied load on the structure, we will multiply it by a partial safety factor so that it will act as a factor of safety for the design.
Okay, next assumption.
Next assumption is that the concrete fiber remains plane after bending. That is why the stress strain curve is linear. Strain curve is linear according to the depth. This much I can.
Okay, define characteristic load.
Characteristic load. So, sir, characteristic load is that value of load uh, below which 5% of the sample will fail.
So what did it mean?
Matlab, sir, if we are designing a structure, so if we take 100 possibilities, then out of that 100 possibilities for that applied loading, 95% of the structures will pass the test and only 5% will fail.
95 structure will pass the test. In what sense?
Yes. Uh, that they can take the load.
And how you are calculating they are taking the load?
How you can you get your question, sir?
How you are calculating, how you are doing the analysis, the structure can take the load.
सर उसके लिए पार्शियल सेफ्टी फैक्टर हम लोग यूज करते हैं.
So by using the partial safety factor, how we can know that the structure can take this much amount of load?
I'm not being able to answer that.
So define limit state.
Limit state is that state up to which the structure is on the verge of failure. So
So what
there
it
are
mean?
two parts of limit state. One is limit state of collapse, and the other is limit state of serviceability. Under limit state of collapse, we have flexure, torsion, shear. Under limit state of serviceability, we have deflection, uh, fatigue, and cracks. Those are the subcomponents of limit state.
Okay, so in which case we are using the higher risk partial factor safety for the load in limit state of collapse or in limit state of serviceability?
In limit state of collapse, we will use higher partial safety factor, because in limit state of serviceability, the structure is deformed but not on the verge of failure, whereas on collapse it is considered to be on the verge of
Okay, so can you tell me the wind code?
wind code.
Hmm.
uh, I IS 1893.
Okay, then what is the code for the seismic load?
So seismic and wind load both are, I think, given in IS 1893.
Have you ever seen the codes?
Yes, I have seen.
But they are not same. They are the different.
Okay, sir. Then I may be telling the wind code wrong, but seismic code is IS 1893.
So right now, which place you are sitting now?
So my city is in zone 4.
Zone 4. Okay. So tell me about this load bearing structure. What do you understand by the load bearing structure?
Load bearing structure I cannot recall, sir.
Okay. So what do you understand by this limiting moment of resistance?
Limiting moment of resistance.
Hmm.
So in for example, if we are designing a beam, then according to its structural capabilities and the type of concrete and steel which is involved, uh, there is a capacity of moment which will be the ultimate moment of resistance. That is the maximum amount of moment that the beam can take.
It is a capacity of the moment or capacity of the beam?
Capacity of the beam.
Hmm. Okay, my last question to you, Divansh. So what do you think?
Yes, sir.
One, we have the single reinforced beam, let be SRB, and second we have the double reinforced beam, let be the DRB. So which
Okay.
one are economical and why?
So singly reinforced beam will be economical, because in doubly reinforced beam, the in the compression reinforcement, the steel is not stressed up to its limit. That is why singly reinforced beam will be economical, because there the steel is stressed up to its maximum limit.
What is the maximum limit?
So 0.87 Fy, where Fy is the yield strength of the steel used.
So you just only want to reach only that stress, okay? You never
Yes,
want the stress in the steel should be beyond that value, right?
yes, sir.
So what is the strain corresponding to this 0.87 Fy stress value?
So for according to IS code, the minimum strain that can be considered for steel will be 0.87 Fy by ES plus 0.002. That will be in tension. And from the graph which is given through interpolation, we can find for different stress value the strain values. For different grades of steel, it will be different.
Now, if the strain in steel is increasing, let it be more than the 0.002 plus 0.87 Fy upon ES, then what will the stress in the steel?
So after reaching the certain limit, the stress becomes constant. I mean, that is the ideal case that has been assumed.
Okay, so let me give you feedback. Devansh,
Yes, sir.
so your final interview is on 18th March, right?
19th.
19th. तो कुल मिला के अभी आपके पास 8 दिन है,
Yes, sir.
right? So from my point of view, right now just prepare RCC,
Okay.
right? So there is a lot of the flaws in your answer parts. What I ask you initially,
Mm-hmm.
starting from the first question, I ask you pre-stress concrete और normal concrete में क्या difference होता है, आप क्या समझते हो,
Mm-hmm.
right? You were giving the answer, but first thing, your answer was not streamlined और clarity बहुत अच्छा नहीं था आंसर के अंदर. Now how
Okay.
to answer? Listen carefully. तो आप
Yes, sir.
स्टार्टिंग करें. Sir, in pre-stress concrete, as name is suggesting, so we are inducing the opposite nature stresses in the section prior to the loading, what we have after the loading. And what is happening due to that, load carrying capacity of the section is increased.
Mm-hmm.
But in this normal RC section, or concrete section, we are not inducing any stresses prior to the loading.
Okay, sir.
And you said in the pre-stress concrete start taking the tension also. That's
Mm-hmm.
why I ask you the assumptions in the LSM. Very basic assumption in whole RCC, we often go across this one. Entire tension is being taken care by the steel and entire compression is being taken care by the concrete. मतलब एक assumption होता है जिसमें हम ये मान के चलते हैं, फ्रेम किया हमने कि टेंसाइल स्ट्रेंथ ऑफ कंक्रीट इज इग्नोर्ड.
जी, sir.
तो हमने कंसीडर किया नहीं, ऑल्दो रियलिटी में तो उसकी टेंसाइल स्ट्रेंथ होता है, बट वी आर नॉट कंसीडरिंग.
Mm.
आपने आंसर के वक्त ये स्टेटमेंट बोला कि प्रीस्ट्रेस कंक्रीट के केस में कंक्रीट के फाइबर टेंशन को रजिस्ट करते हैं. दैट्स व्हाई आई जस्ट वांट टू नो कि एजम्पशन क्या है एलएसएम में. तो ये एजम्पशन को तो वैलिडेट नहीं कर रही है जो आप बात बोले वहां पे, कंट्राडिक्शन हो रही है दोनों के साथ. दैट वाज रॉन्ग थिंग. सेकंड, स्ट्रेस स्ट्रेन कर्व दैट इज ओके कि वो पैराबोला और रेक्टेंगल का कॉम्बिनेशन है, बट दैट इज नॉट ट्रू ऑल द टाइम. आप ये बोलो कि सर वो ट्रायंगुलर भी हो सकता है, मतलब पैराबोला वाला पार्ट, लीनियर भी हो सकता है, या ट्रेपेजॉइडल कुछ भी हो सकता है फाइनल डायग्राम, unless or until it complies with the test results. It is clearly written in the IS 456. जब तक आपके टेस्ट रिजल्ट्स के साथ ये जो कर्व है, जो ग्राफ है, ये कंप्लाई नहीं करता है, हमारा जो कर्व होगा वो रिलायबल नहीं होगा, उसको आप यहाँ पे अलाउ नहीं करोगे.
Okay,
अगर
sir.
वो जो टेस्ट रिजल्ट्स है वो कर्व को यहाँ पे रिलायबल करते हैं, कॉम्प्लाइंस करते हैं, मतलब जैसे जैसे टेस्ट रिजल्ट्स हैं आपको कर्व भी
Mm-hmm.
बिल्कुल वैसे ही बन रहा है, देन यू कैन टेक एनी शेप. कोई हार्ड एंड फास्ट रूल नहीं है कि हमेशा यही रहेगा. इट इज क्लियरली रिटन इन द IS 456. इट इज टोटली बेस्ड ऑन द टेस्ट रिजल्ट्स,
Okay,
राइट.
sir. Yes,
एंड
sir.
द आपने बोला कि मैक्सिमम स्ट्रेस इन द स्टील, दैट इज नॉट द मैक्सिमम स्ट्रेस. आप ये बोलो कि सर हम हमेशा स्टील में चाहते हैं वो यील्ड करे, एंड फॉर
Mm-hmm.
दैट पर्पस one thing, we need the minimum strain 0.002 plus 0.87 Fy upon ES. At least this strain should be in the steel or more than that value, because when the steel is reaching this strain we are getting the 0.87 Fy, that is a yield stress. So what we have now, this is a design stress basically for the steel. We always want steel to be yield, and if strain in steel is going beyond that value, that is more than strain, this 0.002 plus 0.87 Fy upon ES, now stress in steel is constant, because this is the design curve for the steel. Initial part linear, after that we have some part non-linear, उसके बाद वो horizontal बन जाता है,
Yes, sir.
right.
Mm.
So one more question that I asked from you, it was the like load bearing structure.
हाँ.
Load bearing structure, आप simply ये बोलो कि sir, when we don't have the combination of the beam and column,
हम्म.
slab is directly resting on the walls. और जो walls होती हैं, जो brick masonry wall है, वो लोड bearing wall है. अब जितना भी लोड है वो स्लैब से बीम में जा रहा है, सॉरी स्लैब से वॉल में जा रहा है, वॉल से होता हुआ हमारे नीचे फाउंडेशन में चला जाएगा. बट राइट नाउ अगर मैं फ्रेम स्ट्रक्चर की बात करूं, स्लैब से लोड बीम पे जाएगा, बीम से कॉलम पे जाएगा, कॉलम से फाउंडेशन और फुटिंग में, अल्टीमेटली वहां से सॉइल में ट्रांसफर हो जाएगा. दैट इज अ फ्रेम स्ट्रक्चर. तो लोड बेरिंग स्ट्रक्चर एंड फ्रेम स्ट्रक्चर बोथ आर द डिफरेंट थिंग्स. कोड भी मैंने आपसे पूछा, जैसे कैरेक्टरिस्टिक लोड, आप उसका भी डेफिनेशन गलत दिए. राइट, आप ये बोलते सर कैरेक्टरिस्टिक लोड, लोड की वो वैल्यू है जो हमने स्ट्रक्चर पे कंसीडर किया, और 95% थ्रू आउट द लाइफ ऑफ द स्ट्रक्चर, स्ट्रक्चर के ऊपर जो लोड आएगा उससे कम ही रहेगा.
एक्चुअली यही बोलना चाहा था, शायद ठीक से बोल नहीं पाया.
बट
स्ट्रीमलाइन जैसा कि आपने
आप
बोला.
उसको स्ट्रेंथ के टर्म में ले गए.
हम्म.
आप उसको स्ट्रेंथ के टर्म में ले गए. आपने बोला टेस्ट रिजल्ट 5% इससे नीचे होने चाहिए. नहीं, ऐसा नहीं है. आप ये बोलते कि लोड जो रहेगा वो 95% ये प्रोबेबिलिटी है कि उससे कम ही आएगा स्ट्रक्चर के ऊपर.
यस सर.
राइट. एंड these are the things. Anything else you want to ask from my side?
नहीं सर, ये.
प्रेपरेशन
और.
करो अभी देवांश.
यस सर.
हम्म, चलिए ओके ना देवांश.
और सर, ये लाइक आरसीसी के लिए IS 456 तो पढ़ना ही है सर, उसके अलावा भी और
एक
कुछ.
कोड पढ़ ली तो मोर देन सफिशिएंट है देवांश. अगर कोड में एक एक जो स्टेटमेंट लिखा है अगर आपको क्रिस्टल क्लियर है, तो मुझे नहीं
जी.
लगता फिर कोई चीज पढ़ने की जरूरत है, क्योंकि आपने बाइबल पढ़ लिया सिविल इंजीनियरिंग का.
ओके, ओके.